Hello dear friends, welcome to my channel. Today's discussion is complex analysis. So friends, this problem is very interesting. This is the residue theorem. I apply residue theorem. At first I have to draw diagram. Okay. So this is real and this is imaginary. Okay. So friends, I have already complete this problem. Now I can write this integration in this way that this is my j. Okay, j equals to this and fz equals to, let's take fz equals to 0 to infinity. Okay, and root over x whole to the power n minus 2n plus 1 can be written e to the power ln z divided by 2n plus 1. Okay, so this way it can be written, and z square plus 6z plus 8. Okay, this is a technique, branch cut. Okay, this technique is branch cut technique. Now integration fz dz. Okay, this line is called gamma and this is the radius is epsilon. Okay, radius is epsilon to epsilon. Yeah, and this is my total length is, this is my r. In here it is r, it is r. So this port, this top, this minus is this distance is epsilon. Okay. Okay, so friends, fz tz can be written, and this curve is called, this curve is c. Okay, c curve, this is the gamma. Okay, capital gamma, this path is called gamma. Okay, so fz dz equals to 1 by gamma fz dz plus 1 by small gamma, because this area, this path fz dz. Okay, now it can be written this way that small r. Okay, radius small r, yeah, there is, you can say epsilon to capital R fz dz and plus epsilon r, sorry, can be written that this is epsilon capital R fz dz. Okay, so this way it can be written total four part. Okay, so now I will apply residue theorem. So my pole, what is my pole? My pole is -4 and -2. How? Because z square plus 6z plus 8 can be written z plus 2 into z plus 4. Okay, so pole equals to -2 and -4. Okay, so this way we can get now this is equals to now integration, we can say integration fz dz equals to 2 pi I sum residue f, so it can be written as 2 pi I. Okay, 2 pi I. Now residue, you have already learned that how can I find out the residue. Limit z tends to and 2n plus 1 root over z divided by z plus 4 and plus limit z tends to -4 2n plus root over z divided by z plus 4. Okay, so this way it can be written z plus 2, sorry, not z plus 4, z plus 2. So now we get this value is 2 pi I e to the power I pi divided by 2n plus 1, and just putting the value because all are minus minus. Okay, so it is n 2n plus 1 2 to the power 2n plus 1 by 2. Okay, -2 just I am just putting, and minus e to the power I pi divided by 2n plus 1 2n plus 1 root over okay 2n plus 1 divided by 2, not 2, yeah, okay, divided by 2 into 2 divided by 2 pi I. After that we can write e to the power I pi divided by 2n plus 1 into 2 to the power 2n plus 1 minus 2 to the power 2n plus 1 okay 1 by 2 to the power n plus 1 divided by, I can write this way, this is a very simple, 2 divided by 2n plus 1. Okay, this is clear, this is clear concept. Okay, let's go friends. Now very nice technique that r epsilon, okay, r epsilon this portion epsilon r, this fz dz, r to epsilon e to the power ln z divided by 2n plus 1 plus pi I divided by 2n plus 1 divided by z square plus 6z plus 8, okay, into dz. Now it can be written this way: epsilon to capital R minus e to the power pi I divided by 2n plus 1 e to the power ln z divided by 2n plus 1 divided by z square plus 6z plus 8 into dz. Okay, no problem. Now it can be written as minus e to the power pi I divided by 2n plus 1 integration epsilon to r fz dz. So whatever we get epsilon capital R fz dz plus r epsilon fz d equals to, very simple, 1 minus e to the power pi I divided by 2n plus 1 into epsilon r fz d. Okay, so fz dz we can write this way, that it can be written as e to the power pi I divided by 2n plus 1. Okay, okay, another is minus 1 divided by 2I e to the power I pi divided by 2n plus 1 e to the power I pi divided by 2n plus 1. Okay, now it is the very good idea that 2n plus 1 into 2 into 2. Okay, so into 1 by 2, yeah, and I is also common, so it can, I can multiply in here I. Okay, and in this field is equal to j as epsilon. Now friends, it can be written as minus I into minus I into e to the power I pi divided by 2n plus 1 into sine So this value is equals to, can be written sine pi divided by 2n plus 1 into j. Okay, j is this portion, fz into dz is equal to j, because epsilon tends to 0, r tends to infinity. So friends, this is my total work. Now I have to check this value. Okay, this value I have already, I got these total values of the complex analysis. Now, so integration gamma fz dz. Okay, integration gamma fz dz equals to, you can, you have to take that z equals to r into e to the power I alpha. So dz is equal to r into I into e to the power I alpha. Okay, so this equals, this can be written as 0 to 2 pi. Okay, 0 to 2 pi infinity r into e to the power I alpha whole to the power 1 by 2n plus 1 divided by r e to the power I alpha, just putting the value in here. What is the 6z plus 2? So r e to the power I alpha whole square plus 6 into r into e to the power I alpha plus 8. Okay, no problem. R into e to the power I alpha plus 3 minus 1. Okay, so d, so it can be written dz is equal to, d alpha r into e to the power I alpha. Okay, so I hope it is clear for everyone. Yeah, so now what will be result? Okay, now you have to do some calculation. After calculating the total work, so we have very simple that this value is, this equals to, less than equals to, okay, r into 1 plus 1 by 2n plus 1 and 0 to 2 pi and 1 by r square plus 6r plus capital 8. Okay, so it is into d alpha. Okay, I can write d alpha, which is tends to 0, because as r tends to infinity. Okay, so I hope it is clear. Okay, so next is what is the value? 1 by gamma fz tz. Okay, this is very fine problem. So whatever I have to choose, I have to choose z equals to epsilon e to the power I alpha. Z is equal to epsilon I alpha, and so dz equals to epsilon e to the power I into e to the power I alpha into d alpha. So we get same values. So we can show epsilon, so it is 0 if epsilon tends to 0. Okay, so this is the very simple Jordan lemma. I think that this is called also Jordan lemma. So whatever I get these two factors, fz dz, equals to epsilon r fz dz plus r epsilon fz dz. Okay, so r epsilon fz dz, so we can write this way, that minus 2i e to the power I pi divided by 2n plus 1 into sine pi divided by 2n plus 1. Very simple, friends. And now you get sine 2 pi I n plus 1. This can be, and also it is multiplied with j. Okay, so this value I have already got. I got this value, and this value is very simple. This value we got that pi I, okay, pi I e to the power I pi divided by 2n plus 1, 2n plus 1 root over 2, okay, minus 2 to the power 2 divided by 2n plus 1. I cut, okay, I cut, and we get the value is j equals to pi by 2, 2 to the power 1 by 2n plus 1 minus 2 to the power 2 divided by 2n plus 1. Okay, and cosec pi divided by 2n plus 1. I hope then it is clear for everyone. Thanks for watching, and please check my total work, because it is very helpful for all. Okay, I just change my font size. Okay, please check how I solve this problem. The problem is very fantastic and very easy and conceptual.